1 minute ago, something arrived. Not with a flash, not with a roar, but with silence so complete it felt like the universe itself held its breath. For weeks, the giant object had been nothing more than noise, a statistical ghost buried in automated data streams from telescopes scanning the Kuiper Belt. Software flagged it 6 times as irrelevant, dismissed, ignored. Just another blip in the cosmic background. But this ghost refused to die. Every time the algorithm filtered the data, the signal returned. Same location, same motion, same impossible signature. Objects that far out, cold rocks, distant comets, inert debris. They fade, they blur into the darkness and disappear. That's how space works. That's the rule. But this one didn't fade. It grew clearer, sharper, brighter. By the 3rd week, the anomaly wasn't sinking into darkness. It was stepping out of it. The detection system that first caught the giant object wasn't designed for this. It was built to find small, fast-moving objects, near-Earth asteroids that might pose a threat. Rocks a few hundred meters across, maybe a kilometer at most. The software had thresholds, brightness limits, size filters, anything bigger than those parameters. The system assumed was a glitch, a sensor error, a cosmic ray hit, background noise. So, when the giant object first appeared in the data, the algorithm did what it was programmed to do. It threw it away. 5 more times the pattern repeated. Detection, flagged as noise, deleted. But on the 7th pass, something changed. The object had drifted closer, just enough for its reflected sunlight to cross the brightness threshold. Just enough for the system to say, "Wait." That's when the automated alert pinged 3 observatories simultaneously: Cerro Tololo in Chile, Mauna Kea in Hawaii, the European Southern Observatory in the Atacama Desert. Standard protocol for anything unusual. Most of these alerts turn out to be nothing. A satellite glint, a miscalibrated sensor, a piece of space junk catching the sun at just the right angle. But this one was different. The first astronomer to review the data paused when the motion plots appeared on screen. A long, slow drift. Too precise, too controlled. The first human to actually see it was an astronomer on late shift at Cerro Tololo Observatory in Chile. The motion plots appeared on screen during routine data review. A long, slow drift, too precise, too controlled. This wasn't wandering, this was approaching. When the trajectory calculations were run, the result was chilling. This wasn't a small fragment. This wasn't a dirty snowball tumbling through the void. This thing was huge. The data was forwarded to 2 partner observatories. Within 48 hours, 3 independent teams confirmed the same impossible detail. The object's brightness curve suggested a body between 60 and 140 kilometers wide, up to 100 times the size of 3I Atlas. That alone was historic. No interstellar object this large had ever been detected entering the solar system. But the second discovery was worse. Trajectory modeling revealed the giant object was not just entering the inner system. It was threading itself onto a path that would intersect the corridor 3I Atlas was traveling through. Not near it, not adjacent to it, directly through it. A 100 times larger interstellar body heading straight toward the same region of space as Atlas. Not random, not chaotic, impossible. Yet, there it was. And with that realization, every observatory from Chile to Hawaii to Australia switched from curiosity to full alert. Something enormous was coming, and it wasn't drifting. It was arriving. The moment brightness calibration confirmed the object's scale, disbelief swept through the scientific world. Interstellar objects aren't supposed to be big, The largest ever discovered, 2I Borisov, was barely a kilometer across. Even Oumuamua was only about 100 meters long. They're tiny shards, fragments broken off ancient planetary systems, not hulking giants drifting between stars. Yet here was something so large. Its luminosity resembled that of a moon. At first, the size estimate seemed like a calculation error. Maybe the object had unusually high reflectivity. Maybe its surface was shiny volatiles. Maybe the telescope sensor was misaligned. But as more instruments locked onto it, the truth hardened. This behemoth wasn't reflective. It wasn't glittering with ice. It was dark, charcoal black, absorbing nearly all sunlight that touched its surface, which meant the brightness readings weren't exaggerating its size. They were underestimating it. A dark object that big should have been detected long before it crossed into the heliosphere. Yet it slipped through the boundaries of the solar system like a phantom. Only when it reflected the smallest sliver of sunlight did anyone notice it was there at all. Its speed made things even stranger. Interstellar bodies typically barrel into the solar system at extreme velocities, 50,000 to 200,000 mph, accelerated by gravitational tides and ancient trajectory arcs. But this one drifted inward slowly, suspiciously slowly, almost too slowly. Its inbound velocity was just 18 kilometers per second, far below what models predict for an object of its mass entering a star's gravity well. Some theorists speculated it must have passed through dense dust fields that stole momentum. Others suggested magnetic braking from interstellar plasma streams. But the most whispered theory was the most unsettling. It slowed down on purpose. No one dared publish that interpretation, not yet. But inside private Slack channels and encrypted research groups, astronomers admitted what they feared. This was not acting like a natural object. This was behaving like something with intention. The giant object was still days from the inner system, yet already it had shattered every assumption about interstellar objects, and its trajectory was tightening, straight toward 3I Atlas. At first, researchers thought it was coincidence, celestial chance. After all, space is vast. Even with billions of wandering objects, two interstellar travelers crossing paths inside one solar system should be statistically impossible. But with each new observation, the coincidence unraveled. The giant object was not merely passing near the path of 3I Atlas, it was locking onto it. Trajectory simulations run by JPL, ESA, and Pan-STARRS all showed the same chilling result. The newcomer's path was converging with Atlas's corridor to within a margin of just 0.03 astronomical units, a razor-thin distance on astronomical scales. The solar system had become the stage for a meeting billions of years in the making. No random object wanders into such precision. No leftover debris falls into alignment with another interstellar traveler unless they share an origin. Scientists began re-evaluating every possibility. Theory 1, sibling fragments. Perhaps both objects were shards of a world shattered long ago, pieces hurled across the galaxy until fate drew them together again. Theory 2, binary travelers. Maybe the two had once orbited each other as part of a binary system, separated only by stellar tides or gravitational slingshots. Theory 3, shared catastrophe. A supernova could have flung both objects outward on parallel trajectories, their paths diverging slowly over eons, until the solar system's gravity reunited them. Theory 4, the one no one wanted to acknowledge. The alignment was not natural at all, because the giant object wasn't just heading toward the same region, its trajectory was adjusting. Minute but measurable course corrections showed up in two independent data sets, not enough to scream propulsion, but enough to indicate its path was not purely ballistic, not fully dictated by gravity. Something was guiding it. Atlas, for its part, continued tumbling unpredictably as always, but even its minor trajectory shifts seemed to resonate with the newcomer's approach. The two bodies were being drawn together by more than gravity, something ancient, something shared, something unknown. And as observatories realized the alignment was deliberate or impossibly precise, they knew the solar system was about to witness an encounter with no precedent in human history. The first close-range measurement stunned everyone. This wasn't the jagged, chaotic silhouette of a comet. This wasn't the rugged outline of an asteroid. The giant object drifted through space like a monolith, smooth in some places, sharply contoured in others, wrapped in a charcoal-gray skin that swallowed almost every photon that touched it. From a distance, it appeared nearly invisible, like a void carved into the starfield. Only when sunlight struck it at a grazing angle did its true form begin to reveal itself. Spectral analysis showed an albedo so low it rivaled the darkest known asteroids, bodies coated with carbon-rich compounds built over billions of years. But this surface wasn't natural soot. It wasn't cosmic dust. Scattered across its exterior were patches that reflected more brightly. Irregular shapes that glinted like exposed metal or fused stone. These patches didn't fit neatly into any model of natural space weathering. They weren't symmetrical, they weren't patterned, and they weren't random either. Something had altered the surface in ways scientists couldn't explain. As imaging resolution improved, faint linear features appeared across the object's midsection. Long grooves running parallel to one another, too straight, too evenly spaced to be impact scars. They resembled stress fractures, but not from collisions. These looked internal, as if the object had been compressed from within, its outer shell buckling under forces that originated deep inside. One research team suggested these could be remnants of thermal expansion, evidence that the giant object had once been molten, its core cooling and contracting over millions of years, leaving behind surface cracks. But the spacing was wrong. The depth was wrong. The geometry was wrong. Natural thermal fractures don't form such clean parallel lines. These looked machined. When telescopes in different wavelengths were pointed at the giant object, each revealed a different story. In visible light, the charcoal surface appeared nearly uniform, a void against the stars. In infrared, thermal patterns emerged, hot spots and cold zones that didn't match any model of passive heating. In ultraviolet, faint emissions flickered across certain regions, like dying embers buried beneath ash. And in radio wavelengths, silence. Absolute, complete silence. Most rocky bodies in space emit faint radio noise, charged particles interacting with cosmic radiation, creating a soft background hum. But the giant object? Nothing. It absorbed radio waves the same way it absorbed light, like it was built to be invisible. The European Space Agency's spectroscopy team ran chemical analysis on the light reflected from the object's surface. What they found defied standard classification. The spectrum showed iron, silicates, carbon compounds, but also elements that shouldn't exist together. Heavy metals typically found near stellar cores, alongside volatile compounds that should have evaporated billions of years ago, and isotopes, radioactive signatures that indicated formation in an environment with extreme radiation. Not near a normal star, not in a quiet nebula. Somewhere violent, somewhere short-lived, somewhere dead. Formation models suggested the object might have originated near a supernova remnant, or perhaps a magnetar, a neutron star with magnetic fields so intense they twist space-time itself. But the most unsettling analysis came from planetary formation simulations. When chemical data was fed through models that simulate how planets and moons are born, the models kept failing. The giant object didn't match any natural formation pathway. Its composition was too perfect, too balanced, too precise, as if the elements had been deliberately arranged, not to create a world, but to create a vessel. Infrared scans revealed something even stranger. Beneath the surface, thermal imaging detected pockets, hollow cavities, not cracks, not fractures, chambers, some large, some small, arranged in patterns that defied easy explanation. In natural worlds, voids form chaotically, random pockets of gas, ice, or empty space left behind by ancient geological processes. Yet these voids were arranged almost rhythmically, as if the object had once undergone internal processes that shaped it from within. Even stranger was how heat flowed through those regions. It didn't disperse randomly. Instead, thermal gradients curled in gentle spirals, like heat following the grooves of an internal lattice. It was the kind of distribution you'd expect from something that once had molten layers, or from a structure that had been engineered to channel energy. As sunlight struck the object, those thermal spirals glowed briefly, revealing textures invisible to the naked eye. Ridges aligned with the spirals, faint but unmistakable. Something inside this giant had shaped its body in ways ordinary cosmic debris never experiences. Not asteroids, not comets, not planetary fragments. It was as if the object remembered something, some ancient stress, some forgotten event, some internal transformation that left scars and patterns across its entire being. Whatever this thing was, it was not a simple relic of cosmic randomness. It was a body with history, layered, structured, shaped, a survivor of something enormous. And the closer it came to Atlas, the more those layers whispered of a story waiting to be uncovered. But the strangest discoveries came when the giant object began interacting with the solar wind. Charged particles flowing from the sun began to bend around it in patterns that made no sense. Instead of forming a typical bow shock, the solar wind formed a stretched magnetic shadow behind the giant, a wake that shimmered with fluctuations like ripples trailing behind a ship in dark water. Instruments aboard the Parker Solar Probe detected distortions in particle flow that didn't match any known profile of natural objects. Something inside the newcomer was interacting with the solar wind, subtly yet undeniably, not with an active magnetic field, but with a memory of one. Certain minerals, especially iron-bearing silicates, retain magnetic signatures from the environment in which they formed. These magnetic echoes can survive billions of years, and this object carried them in abundance. When hit by the solar wind, those echoes reawakened, faintly pulsing like a heart that hadn't beaten in ages. It was like watching a fossil respond to sunlight. The magnetic map built from these particle interactions suggested something incredible. The object had once existed in a region of space far more magnetically intense than the solar system, perhaps near a massive young star, perhaps inside a dense protostellar cluster, or perhaps near the aftermath of a supernova where magnetic fields twist violently as stellar remnants collapse. Every discovery added a new layer of strangeness. The object wasn't just a piece of rock. It was a time capsule from a part of the galaxy we could barely imagine. Its mineral composition aligned with environments rich in heavy elements, places where stars lived violently and died spectacularly. And then came the most chilling observation. As the giant object entered regions of denser solar wind, faint auroral glows rippled across its surface. Ghostly lights, too dim for the naked eye but unmistakable in ultraviolet scans. The object lit up, like a dying world remembering what it once was. It wasn't alive, but it wasn't dead either. It was a relic carrying the magnetic scars of a star long gone. And now, it was awakening inside our solar system. The countdown to closest approach unfolded with tension no simulation could capture. For days, the two interstellar wanderers had been inching closer, their gravitational fields stretching toward one another like invisible fingers. Telescopes across Earth, in orbit and on the far side of the Moon, locked onto their positions with relentless precision. Every frame, every pixel, tightened the sense that something extraordinary was about to happen. Then, at 3:12 UTC, the distance between them reached its minimum. They didn't collide. They didn't even brush against one another. Instead, the massive newcomer slipped past 3i Atlas in a silent, breathtaking glide, so close that tidal forces momentarily intertwined their motions. Atlas, small and frenetic, shuddered with a brief tremor, its spin altering, as if acknowledging the presence of something immeasurably older and infinitely heavier. Dust plumes burst from its surface, not in chaotic jets, but in graceful arcs that revealed fresh interior layers to distant instruments. The giant object reacted too. Its charcoal skin absorbed the encounter with an eerie calm. But subtle waves pulsed across its thermal spirals, as though the ancient relic were responding to the passing whisper of its smaller counterpart. Solar wind around them twisted, bending in patterns that resembled two shadows merging before parting again. For 40 seconds, the universe held its breath. Two travelers, born in star systems unknown, shaped by catastrophes unseen, moved alongside each other in a dance billions of years in the making. And then, just as quickly, they drifted apart, their paths diverging once more, each continuing its lonely journey through the galaxy. But the encounter left marks on their trajectories, on their surfaces, and on humanity's understanding of the cosmos. It was more than a near pass. It was a cosmic dialogue, a moment where two fragments of forgotten worlds crossed paths inside our sky, offering a glimpse of a history written long before Earth even existed. The universe had opened a door for less than a minute, and in that minute, everything changed. As the giant object receded into the outer darkness, scientists scrambled to analyze every byte of data collected during the flyby. What they found raised more questions than answers. During the closest approach, both objects experienced subtle gravitational distortions. Instruments detected tidal flexing, microscopic shifts in their surfaces caused by the immense gravitational pull they exerted on one another. For Atlas, these distortions were expected. Its surface had always been unstable, prone to outbursts and shifting terrain. But the giant object, supposedly a cold, inert monolith, showed flexing too, which meant it wasn't entirely solid. Deep beneath its charcoal skin, there were layers, regions with different densities, possibly even pockets of liquid or semi-molten material trapped inside for billions of years. This wasn't just a dead rock. It was a world, frozen mid-transformation, preserved in the deep cold of interstellar space. Spectroscopic analysis during the flyby revealed something even more startling. As the two objects passed within 0.03 AU of each other, faint gas emissions vented from the giant's surface. Not explosive, not violent, but deliberate, controlled. The venting occurred in precise locations, aligned with the thermal spirals detected earlier. It was as if the object was exhaling, releasing pressure built up over eons, triggered by the gravitational tug of Atlas. Chemical analysis of the gas showed compounds rarely seen in interstellar objects, noble gases, complex organics, isotopes that suggested formation near a dying star, and traces of water vapor. Not ice sublimating from the surface, but vapor escaping from deep within, evidence of reservoirs hidden beneath layers of rock and metal. The implications hit like a shockwave. If the giant object carried water and organics and complex chemistry preserved from a time before the solar system even existed, then it wasn't just a relic, it was an archive, a messenger from a stellar environment humanity would never see, a fragment of a world that died billions of years ago, now passing through our sky, whispering secrets of a galaxy we're only beginning to understand. But the most haunting realization came from trajectory analysis after the encounter. Both Atlas and the giant object had altered their paths, subtly but measurably. Atlas's spin had changed. Its rotation period shifted by 0.3 seconds, a tiny adjustment, but significant for an object that had tumbled chaotically for millions of years. The giant object's trajectory also shifted. Not randomly, not chaotically. Its new path curved inward, deeper into the solar system, toward the inner planets, toward us. As the data settled, a new theory emerged, one that made every previous discovery feel like a prelude. The giant object and 3-eye Atlas weren't just two random travelers crossing paths. They were part of something bigger, a stream, not a river of water or gas, but a ribbon of debris stretching across light years. Fragments of shattered worlds, broken moons, planetary cores, all traveling together through the galaxy like a cosmic convoy. Streams form when star clusters dissolve, when gravity weakens, when ancient worlds are ripped apart, flinging pieces into the dark like seeds scattered by the wind. If that was true, then more visitors were coming. The implications hit like a shockwave. Humanity had spent generations believing interstellar objects were rare, cosmic flukes that only appear once every few centuries. But what if the solar system was moving through a dense ribbon of galactic history? What if the next decade held dozens of arrivals? Small, large, unknown. The giant's immense size suddenly made sense. Streams don't carry fragments of just one kind. They transport everything, shards of lost planets, broken moons, metallic cores, icy shells, and objects no one can categorize. But the most haunting realization was this. If this was a stream, then the 100X object and Atlas might not be meeting for the first time. They might have been traveling through the galaxy together for millions of years. Two relics of a story humanity was only now beginning to read, and their reunion was happening right here, in our sky. As the giant object moved deeper into the solar system, high-resolution imaging sharpened its silhouette until its surface appeared almost tactile, like you could reach out and run your hand along the scars of its ancient journey. What had once seemed like a featureless charcoal black mass now revealed faint patterns running across its surface. Long sweeping bands, curving gently around its form. These weren't random streaks. They weren't impact lines. They looked structural. Natural objects rarely form such smooth, continuous arcs, unless intense forces have shaped them. The most accepted theory was that the object had once been part of something much larger, perhaps the mantle of a planet that had been torn apart, its internal layers exposed, frozen, and preserved through the abyss of interstellar space. The bands might be remnants of that layering, geological ghosts etched into its skin. But if the giant object was a planetary fragment, what kind of world had it come from? To produce an object this size, with such complex internal structure, the parent body would have been enormous. Perhaps a super-Earth, perhaps a gas giant's rocky core, or perhaps something we've never seen before, a type of world that only exists in star systems we'll never reach. And if that world had been destroyed, what destroyed it? Observations continued. Telescopes tracked the giant's slow descent toward the inner planets. Its new trajectory would bring it within 1.5 AU of the Sun, closer than Mars, though still beyond Earth's orbit. But that was close enough to trigger more activity. As the object approached perihelion, the point of closest approach to the Sun, thermal stress would increase, ice pockets would sublimate, gas reservoirs would vent, the surface would crack and shift, and those internal chambers, those mysterious thermal spirals, might activate. Scientists didn't know what that meant, but the possibility sent chills through every research team. What if the giant object wasn't inert? What if it was waiting for the sun's warmth to wake it up? Meanwhile, amateur astronomers began tracking the object with backyard telescopes. It was still faint, magnitude +10 at best, but visible to those who knew where to look. Online forums erupted with images, speculation, and theories. Some called it the Wanderer, others called it the Sleeper. A few called it the Predator, convinced its trajectory wasn't random, but deliberate. NASA released a statement urging calm, but the statement only fueled more questions. Why was the object approaching so slowly? Why had its trajectory adjusted after the encounter with Atlas? And why, despite weeks of observation, did no one have a definitive answer about what it was? The silence from official channels spoke louder than any press release. Then, 4 days after the flyby, something changed. A research team in Australia detected a new signal, not from Atlas, not from the giant object, but from a third object, smaller, fainter, trailing the giant by several million kilometers. Another fragment, another traveler, another piece of the stream, and it was heading inward too. Within 72 hours, 2 more objects were detected, then 3 more, then 6, all following similar trajectories, all part of the same cosmic ribbon. The stream was real, and it was vast. Humanity stood at the edge of a revelation. For the first time in history, we weren't watching isolated visitors passing through. We were watching an exodus, a migration of ancient debris, pieces of worlds long gone, sweeping through the solar system like ghosts returning home. And we had no idea how many more were coming, or what they carried with them. As observatories around the world adjusted their schedules to track the incoming stream, one question dominated every conversation. Why now? Why, after 4.6 billion years, was the solar system suddenly intersecting this river of ancient debris? Was it random chance, orbital mechanics, galactic drift, or was something else at play? Some researchers whispered about gravitational perturbations from unseen bodies, dark matter filaments, rogue planets nudging trajectories over millions of years. Others suggested the stream had always been there, and humanity simply hadn't noticed until now. But a few, a very few, entertained a darker thought. What if the stream wasn't passing through the solar system by accident? What if it was being drawn here by something we haven't discovered yet, something massive, something hidden? something waiting. In the hours following the encounter, social media erupted. Amateur astronomers posted images of the giant object and Atlas side by side, two shadows against the stars, one massive, one tiny. The images went viral. Millions of people around the world looked up at the night sky, trying to see the visitors with their own eyes. Hashtags trended. The giant, cosmic encounter, interstellar stream. News outlets ran breathless headlines: 100x larger, mystery object targets, interstellar visitor. Atlas encounter, what just happened above our heads? Scientists baffled. Stream of ancient objects entering solar system. But beneath the excitement, there was fear. Not panic, not hysteria, just unease. Because for the first time in human history, people realized we are not alone in this solar system, not in the way science fiction imagined. No aliens, no UFOs, no little green men, but in a deeper, stranger way. The solar system was full of travelers, full of relics, full of ancient things we never noticed until now. And if the giant object could slip past our detection systems for weeks, what else was out there? Telescopes continued tracking both objects as they drifted apart. The data was undeniable. The giant object's trajectory had shifted, not randomly, not chaotically. Its new path curved inward, deeper into the solar system. The calculations showed it would pass within 1.5 astronomical units of the Sun, beyond Earth's orbit, beyond Mars, but closer than anyone had predicted. And the question no one could answer was simple. Would it stop there, or would it keep adjusting? The giant object continued its slow descent. Atlas tumbled onward into the void, and behind them, more travelers approached, silent, ancient, unstoppable. The universe had opened a door, and we were only beginning to see what lay beyond it.